customizing monitors and rules. Okay, we've gotten ourselves to the point where we've got Operations Manager up and running in our day-to-day standpoint. And now we're to the point where we may actually want to take a look at some of the tuning activities that are involved with turning the default management packs that we download off of the management pack catalog and making those really work for our environment. Now, we talked earlier about how these day-to-day operations of Operations Manager, you're going to go through and you're going to resolve alerts, you're going to figure out what the problems are and fix them and set the alert resolution status to resolved. But sometimes you're going to end up with situations where the individual who wrote that management pack may be writing it for an environment that's a little bit different than yours. In your environment, for example, maybe in your environment when processor use goes over 80%, you really want to know, you want to be alerted. But the person who wrote the management pack wrote in the alert to only notify you when processor use goes over 95%. In this case, you may actually want to go through and customize that monitor or rule to ensure that when the condition occurs that you're interested in, that it actually is alerted to you in your Operations Manager infrastructure. Over the next series of nuggets, we're going to go through an existing Operations Manager infrastructure, the one that we've created at this point, and go through all of the different authoring pieces. Now, we're not actually going to author brand new management packs, but what we're going to do is actually customize some of the monitors and rules, and a little later on we'll do attributes and groups and tasks and those sorts of things, so that they make sense for our particular operating environment. In this nugget, we're going to talk about how you can create a management pack for the process of customizing those sealed management packs. Because the management packs that we get typically off of the Microsoft catalog are going to come in a sealed format, we need to create another management pack that we will use for those customization things that we're going to put in there. We're going to do that in this nugget. We're going to look at some existing monitors and rules and also talk about what the differences are between monitors and rules and where they come in handy in Operations Manager. We'll go back over overrides one more time and talk about how overrides can be used to turn off a rule or to change some of the values of a rule, and then we'll go and create some monitors and rules that are valuable for our environment. Lastly, we're going to talk about self-tuning thresholds. As you'll find out, this is going to be, again, the first of a series of nuggets in this middle section of this series where we talk about the customization of the management packs themselves. And so that's what we're going to do here over the next 3 or 4 nuggets in this series. Let me go ahead and minimize this, and I'm going to bring up my Operations Manager console here. And as you'll see, we're focused here on the management packs themselves. Let me switch actually first back over to the monitoring node so we can just take a quick look at the active alerts that are available to us. Now again, we're not interested in the exact alerts that are available, but we'll be aware that from time to time we're going to have situations where the configuration of an application is wrong, or gets changed, or performance is not where it should be, or there's a mismatch of service packs, or performance modules are not able to complete their missions. All of these occur because those management packs have been coded to notify us when those situations actually occur in our environment. Now again, we may find that from time to time we're not really interested, or we need to change some of the values. And we can do that, first of all, by creating ourselves a new management pack. Now what I want to do in this one is I want to create a new management pack by right-clicking on the Management Packs node here under Administration. And when I create a new management pack, I'm just going to call it My Server Performance. And I can put a version number in here if I want. The versioning can be very important with management packs if you change the management packs over time. I'm going to click the next button here, and you'll see that I have the opportunity to include some knowledge in there. This is going to be knowledge that is specific to this management pack and the things that I intend to do with this management pack. If I click the Edit button here, as long as I have the Microsoft Office installed on the computer where this console is installed, it'll pop up Microsoft Word and allow me to enter in some information into this knowledge base article associated with what I'm going to do with this management pack. Now in this case, this is going to be, let's call this updated performance stats for my environment. So I've got the little information here in summary. Maybe I can add some configuration data in here, or additional information, or external knowledge sources if I want. If I click on the File button and choose Save to Operations Manager, what Word is going to do is it's going to flow these changes directly into this screen here in Operations Manager so that my management pack has the knowledge data that it needs so that I can later on go back and figure out what it is. You're going to find that we're going to have to be delving through lots and lots and lots of data to find exactly what we need. So the population of these knowledge pages is going to be very important as your number of customizations goes up over time. Once I'm ready to go, I'll go down here and click the Create button. That'll actually create the management pack for us. Once the management pack is created, then I can use that management pack to actually include some overrides or to include some specific customizations in there that make sense to me. So you see here, here's my server performance. This is the management pack that we just created. If I double click it, there's not much here. There's just the properties of it, the knowledge information that I've included, and then also any dependencies. Obviously, any new management pack is going to be based off of the System Center core library for its basic core information. Now that I have this management pack, I can leverage the use of this management pack for creating things like overrides, or for creating things like monitors and rules. Now I want to take some time here and show you really what monitors and rules are. Monitors here under the authoring node are really a way of identifying the health of a particular part of your environment. Now, and health is very important because we can cause something to occur, like when performance goes over a certain value to kick off an alert. That's more of a rule status. What we're doing with monitors here is looking for whether or not that particular component that we're interested in is considered healthy or not. You can think of a monitor as almost like a state engine. You'll see that monitors here, a lot of monitors have this little pearl icon here. And the little pearl icon can be filled with a number of different things. It can be red if the state is bad. It can be green if the state is good. It can have the little wrench icon in it if the system is under maintenance mode. What this is it determines what the state of health is associated with the element that I'm interested in looking at. Now, if you'll see here, I've actually scoped down the number of management pack objects to just a few here so we can take a look at a few of them here. What I want to take a look at here is Windows Server 2003 operating system, entity health, and then the 4 subnodes available for entity health. By default, for all of the monitors you're going to see 4 roll-up monitors associated with entity health. These, with any of the things that are in your monitors list. Availability, configuration, performance, and security. These are what we call aggregate roll-up monitors. If I click down here into performance, you'll see that I have a number of monitors that are sub to that aggregate roll-up monitor. Available megabytes of memory, percentage of committed memory in use, total CPU utilization percentage. All of these are what we call unit monitors. This unit monitor will fill in green if that CPU utilization is considered healthy, if it is below my threshold percentage. It'll go red if it's above my threshold percentage. In certain circumstances, I can even create 3-state monitors which will have a red, a yellow, and a green for those. You'll notice here that I have roll-ups associated with each of the monitors below them. Those roll-ups effectively allow me to roll up the health associated with all of the individual monitors to provide an aggregate status of how that system is doing. Now let me stop and let's think about this for just a second. What I want to do first to kind of explain this is really minimize this and bring open a little blank sheet of paper here. Now let's think about what we consider health in terms of our computer systems. Perhaps we might consider a healthy computer as one that has a good amount of memory and one that has a decent amount of CPU. Maybe one that its disk isn't full. Now each one of these can potentially have a monitor all its own. That monitor can be green if it's got a good amount of memory. It can be red if the CPU is too high, or in some cases it can even be yellow if we configure those. Now, knowing that memory is perhaps, maybe we don't have enough memory today. Knowing that memory is not enough for our server is one thing, but knowing that how that memory information relates to the overall status of the computer is yet another. What this allows me to do is identify that, for example, when CPU goes bad, the roll-up of all 3 of these monitors together in aggregate lets me know that, in fact, the system is considered unhealthy at this point. And I can even have these monitors relate to other monitors down the line as well. So what this allows me to do is identify what the red icons mean, or when the red stoplight shows up, as opposed to when the green stoplight shows up when I look at my illustration of health inside of System Operations Manager. Let me actually show you where this kind of takes a look at. Let me go back here into monitoring now. You'll see my active alerts. I'm going to click here into computers to take a look at my health. You'll see that I have 2 computers in here, and one is considered healthy and one is considered a warning. If I go under warning and I open, and I want to look at the Health Explorer here, you'll see under the Health Explorer it's going to show all of the different elements that make sense for this computer based off of its role inside of my environment. You'll see here that this entity health has, again, availability, configuration, performance, and security. If I click down under security, you'll see that I have a green checkbox here and a green checkbox here for local application health rollup. And that's green because its security is green also, and the health service security is green, and its data integrity is green, and its data validity check is green. All of these show that, well, going down that entire string of potential states that the computer could be in, that we are considered healthy. A little bit further up here, you'll see that we have a warning because our service pack compliance is not set to the right service pack for the version of SQL that's installed to that computer. Now, this is important because instead of looking at computers from the basis of I'm healthy today because of this element, or maybe that element over there, or RAM or CPU, or installation of the right patches, or what have you, now what I have is a nice tree of roll-ups that tell me overall whether or not that computer is indeed healthy or not. And what that gives me, as we showed before in those day-to-day scom operations, is a good measure of indication for when that computer is in the right status for me to be behaving with it, or interacting with it. Let's go back to the authoring node here. Under the authoring node, and again under operating system and entity health and then performance, you'll see that we have a number of these elements that we're looking at now. These are these unit monitors that we're interested in looking at. Now, we may be interested in looking at those unit monitors and the specific configuration of those unit monitors. We talked before about how maybe the person who wrote this management pack might think CPU utilization at 95% is okay, and that CPU utilization at 83% is still okay. But we want to roll down or back down that CPU utilization percentage. I'm going to right click on this and choose properties to take a look at this individual unit monitor here. You'll see here that we got a name and a description of the unit monitor, and the target is Windows Server 2003 operating system, and its parent monitor is that performance node that we talked about before. The CPU utilization threshold that the author of this management pack has actually created is set to 95% over 3 samples. Now, in your environment, you may not consider 95% to be healthy or below 95% to be healthy. You may again consider below 80% to be healthy. But you'll see here that these are all grayed out. We can't actually adjust the CPU utilization threshold because this is a sealed management pack, and so its configuration is not changeable. What we need to do is actually either create an override for this or create a different monitor and change the value on that monitor. What I'm going to do is show you how that works in both directions. Let me go ahead and close this down. And instead of actually viewing this percentage, what I want to do is right click it, and I want to choose overrides and override the monitor. In this case, I want to override the monitor for all units of type Windows Server 2003 operating system. We bring up that override properties box that we saw in the last nugget. And you'll see here that, unlike what we saw in the last nugget, we actually have some useful information if I scroll down here to the bottom. I have the CPU utilization threshold. That's that 95%. There's the queue length. There's 15%. The number of samples that I want to measure this over is equal to 3. One way that I can update this to change it and customize it for my environment is to click the override button and to change the override setting from 95 to 80. Now what that does is it says, don't actually give me a notification that there's something wrong or that the health is poor for this computer until that CPU goes over 80%. Now you'll see down here at the bottom that I need to select a destination management pack for that change. I can set it to the default management pack, or I can set it to the My Server Performance Management pack as I've created before. It needs to be a target destination for writing that update. Now you'll see that I've done that. The change status has been added. And once I complete that, I've now created a new change, and I've really updated the configuration of Operations Manager and when it's going to notify me. Now I told you that there are 2 ways in which we can actually work with these monitors. And the first is to override them. The second is really to just disable them and create new monitors based off of our own configurations. Let's actually do that now. Sub to this aggregate roll-up monitor here, what I want to do is actually create a new monitor. In this case, it's going to be a unit monitor. This unit monitor, I have an option, as you can see here, of doing quite a bit more than just overriding a few details in an existing monitor. You'll see here that in addition to Windows performance counters, static thresholds and single threshold, which is the monitor that we looked at before, that would be a simple threshold. I can do other things. I can look at Windows services. I can look at Windows events or log files or WMI performance counters or even SNMP information here. So what this allows me to do is add additional monitors into what Operations Manager considers the statement of health for this computer. Let me actually go ahead and create a single threshold monitor here, kind of similar to what we did before. We'll do a simple threshold here, and we'll save that to the My Server Performance Destination Management pack. What we're doing here is we're essentially doing more or less the same thing that we did before, but we're doing so by creating a brand new monitor. So let's call this My CPU Threshold. And in this case, the monitor target is Windows Server 2003 operating system, because that's where we created this monitor. Our parent monitor here is again performance, because it is a performance monitor. I click the next button, and now I have the option of choosing which performance counter I'm interested in. Again, before, all I could do was adjust the existing counters or adjust the existing thresholds. Here, I'm allowed to create brand new thresholds for other notification purposes. I click the Browse button here. This sort of looks very similar to you if you're familiar with Performance Monitor. If I click down here under Objects, and I click down here under Objects, and I'm going to go down to Processor, I believe, so I can take a look at the processor information. There's Processor. And in this case, I'm looking at percent processor time, total. Maybe I can even include all instances if I want. Let's look at percent processor time total and assign that to this performance monitor. Now we'll see the interval as well. How many minutes do I want to provide between samples? How many seconds? How many hours? How many days do I want? In this case, let's say every 60 seconds. I want to actually take a look at the processor time for that server. When I look at that processor time, if I click the next button, I want to see what the threshold is. Now before that was set to 95. Now I want to set it to 80. So that the threshold value when it reaches 80 is considered not healthy. I click the next button again. And you can see here that when it's considered under the threshold, it is considered healthy. When it's considered over the threshold, that's when it goes to critical. And all those roll-ups, all the way through from this monitor, all the way through all the aggregate roll-ups all the way to the top, will tell me that my server is currently in the critical state at this point. I can choose the next button. Now remember, in addition to having that monitor, which lets me know that my server is unhealthy, I may additionally want to create an alert that alerts me in that alerts node to let me know that there's something I need to do. That maybe I need to go and take a look at that monitor and identify that, well, perhaps processor performance is not doing so well today. If I click the checkbox here and I want to generate alerts for this monitor, I want to generate an alert when the monitor is in a critical health state. I can call it my CPU threshold and give it a priority and a severity and even type in some alert description information in here. CPU usage is too high. Once I'm done, I click the Create button here. I've now created a monitor that exists underneath this performance aggregate rollup monitor, my CPU threshold. If I wanted to, later on, I could go back to the old total CPU utilization percentage and look at an override and even disable that monitor so that I'm using mine instead of the other monitor. Now what's interesting is I can create my own sense of aggregate roll-up monitors as well. Maybe my consideration of health has not so much to do with performance, but maybe it has to do with a combination of other elements. If I right-click under the performance here and create another monitor, I can create my own aggregate roll-up monitors here. If I do that, let's call it my definition of health. In this case, I'm going to have the same monitor target Windows Server computers, and I'm also looking at performance, and I want to put that back into my server performance. I choose the next, and now I have the choice of choosing what I consider to be my health roll-up policy. Now, when I create these aggregate monitors, it gives me the flexibility of determining what I consider to be healthy and when. You'll see here that if I have a number of computers in this group, and one computer is in the worst state of any member, and one computer in this group is considered unhealthy, well, then the entire group then is considered unhealthy. This goes back before to our little diagram that we showed here. In this case, if any one of these is considered unhealthy, well, then we fail the entire group. Or alternatively, I can say the best state of any member. In this case, maybe I have a number of computers in an array. Maybe I've got a web farm, for example, and as long as some of them are up, then I consider the farm to be okay. But if the group state actually goes too poor, then I'll actually consider it to be a failure. In this case, let's consider it the worst state of any member. If any one of my members goes down, I want that group to be considered critical at this point, or unhealthy. I choose Next. And I can also choose, just like before, to generate alerts about that to happen. So when my definition of health actually becomes poor, when it becomes critical, I'm going to say, there's a problem. I'm going to click the Create button here. And that creates actually the aggregate roll-up monitor, as you'll see, now that exists below my statement of performance. Now that I've created my definition of health as an aggregate roll-up monitor, what I can then do is create individual unit monitors sub to that aggregate roll-up monitor that include different statements of health. Again, maybe it's performance-based, maybe it's event log-based, maybe it has to do with WMI or SNMP. All of those I can then add in to further include into that statement of health, like we saw before, what we consider healthy and what we consider unhealthy. Now you'll see here we have another type of monitor we haven't talked about at this point, and that's a dependency roll-up monitor. Let's think about different computers in our environment, right? In our environment, we may have different computers that are dependent on other computers. Or we may have services on one computer that are dependent on other services, or elements that are dependent on other elements. Think about a web server. And that web server has a SQL server that it works with. If that web server is having a problem, we may have that the statement of health show that it has a problem. But if that web server is not having a problem and its SQL server is having a problem, well, the service that is running on that web server is having a problem. We may not have the counters for that SQL server. We may not have the performance metrics or the event log data from that other server. But we know that if the SQL server is having a problem, well, the web server is having a problem too today. Because of this, we know that that SQL server is dependent, or excuse me, the web server is dependent on the SQL server. And so what a dependency monitor allows us to do is look at different things in our environment, or completely different areas of our environment that we are dependent on for the fulfillment of whatever mission we're trying to do. Or if our service is producing a website, I may have 2 or 3 or 4 n number of different servers and services and elements in my environment that I'm dependent on to make sure that that web service actually runs. So let's take a look at this dependency monitor. I'm going to create one here. I'm going to give it a name, my dependency monitor. And then you'll see here that my default monitor target, because I've created this under Windows Server 2003 operating system, is just that. What I want to do, though, is I want to see what other things I might be dependent on for the functioning of my Windows Server 2003 servers. If I click the Select button here, you'll see that I have all the options of all the different targets that I can potentially choose. Let me go ahead and scroll this to the right. For Windows Server 2003 computers in my environment, I have a number of things that I'm actually checking at this point, like network adapter information or disk partition information. If I want to take a look at disk partition and consider that disk partition to be dependent, or the health of my service to be dependent on that disk partition, I can choose that as the monitor target here. You'll see that my parent monitor is availability, and I need to change that destination management pack to my server performance. When I click the Next button, you'll see that I now have a list of the dependencies associated with what that target was. You'll see down here I have Windows Server 2003 logical disk. And if I scroll down here, I have a couple of new statistics that I can pull in to my statement of health. You'll see I have logical disk free space, logical disk availability, average disk seconds per read and transfer and write. If I select logical disk free space, what that means is that if the logical disk free space information, if its status, if its state is considered healthy, then I consider myself to be healthy. If it's not healthy, then I'm not healthy. That's based off of the health roll-up policy. Just like we had before, we have the worst state of any member, or maybe the best state of any member. But when we do dependency monitors, we can also choose, if we have a number of computers, what's the worst state of a specified percentage of members in good health. You'll see here that we have 60%. As long as 60% of our computers are healthy, then we're considered this to be okay. This makes a lot of sense, again, when we have multiple computers in that environment, when we want to make sure that at least some of them are available for use. If we see here if monitoring is unavailable, then we roll it up as an error. Or if we're in maintenance mode, we actually simply ignore the monitor. If I click Next, I can also generate alert settings associated with that monitor just like I did before. If I click Create, I go ahead and create that dependency monitor associated with the monitor that's already in place. I'm going to go ahead and hit the Save button here. And you'll see that now, if we scroll back up to Disk Partition, Entity Health, Availability, you'll see my dependency monitor that exists there. And so this is the way that you can create additional monitors for looking at the health of computers in your environment. Again, this relates back up under the monitoring node, not necessarily to the active alerts, although you've seen where we can create alerts when health changes, when the health state changes. You'll see it relates here to the computers node, where we see the different health statuses of the different computers in our environment. And so these are monitors. Now there may be some situations where you're not interested necessarily in creating a monitor, but what you want to create is more of a rule. You'll see here that I have a number of different rules that are available to me. A lot of rules based off of the management packs that come into my environment. Now, rules do a couple of different things as well. They don't necessarily look at state information, but they can kick off perhaps an alert whenever an alert needs to occur. Or they can collect information that I can use back here under my monitoring node for populating those graphs and charts and things. Let's actually take a look at a rule here. You'll see here physical disk average disk reads per second for 2003. This one relates to the Windows Server 2003 physical disk. If I double click this, you'll see what I'm actually doing is collecting information. I'm collecting information from performance. If I click the View button here under the rule configuration, you'll see that I'm collecting from the physical disk object average disk seconds read information, and specific to instance information as well. I'm collecting it over every 5 minutes. If I click the Close button here, instead of actually having a state-based information or a state-based understanding of the health of my system, I want to have instead an ingest of information, an ingest of performance information that I can look at in a graphical format. Let me click close here. If I go back to the monitoring node, remember when we showed, we scrolled down here and took a look at some of the different elements in here? Here's Microsoft Windows Server, and we looked at disk performance, for example. This is the location where those rules actually pull in their data so that we can view what the disk information is for those computers. If I want to eventually populate this later on when we talk about views, I'm going to need to gather this information through some mechanism, and this is the way that we do it. Let me click back here on the authoring node again. What I want to do here is create a new rule. I can do that by right-clicking Rules and create a new rule. You'll see here that there are a number of different types of rules that we can create. The first are these alert-generating rules that are event-based. You'll see here that based off of a CSV text log or an NT event log or an SNMP trap or a syslog, I can actually create a rule that defines when an alert should be generated based off of the contents of those logs. Alternatively, I can use a rule to just collect data. You'll see I can collect data based off of events or based off of performance or even probes that are sent out. If I look at event-based collection rules, you'll see the same sort of elements in here: SNMP events, NT event log, syslog, WMI event. If I look down under performance-based, I can look at SNMP performance or WMI performance or Windows performance. In this case, again, I'm not looking at the state, but just pulling in information. Now we have to be very careful here because the level of information you're going to be pulling in from the computers in your environment every time you create a new rule will increase the amount of information you have to store in your database. So be careful with these. You're not just storing binary zeros if it's bad and ones if it's good. In this case, you're storing a lot of information associated with the event log or the performance log for that computer. Keeping up with our theme of Windows performance, let's look at this performance-based rule right here. And again, I'm going to include that in the My Server Performance Management Pack. If I scroll up and choose the next button here, I can give it a name, collecting, C-O-L-L-E-C, collecting memory performance. I can choose a rule category if I want, a custom rule, or I can give it even different predefined rules if I want. And then select that towards a rule target. In this case, I'm going to choose the rule target as Windows Server 2003 computers, which means that I want to target this rule against computers that fulfill that Windows Server 2003 computer, the rules associated with it. If I click OK here, and I choose the next button, I can, just like before, specify the performance counter that I'm interested in looking at. If I choose Browse, and if I go down here and look for memory again, let's see, there's the memory information. Oops, that's one too far down. I can say percentage committed bytes in use. That's a good understanding of how my memory behaviors are. If I choose percentage committed bytes in use and click OK, I may want to include an instance if I need to there, and also change the interval, maybe from minutes to seconds if necessary, and choose the next button. The last thing I have to do here is identify how much data that I want to pull into my database. And as I said before, you have to be careful with this because it's a lot of data that's going to come in. Imagine how big your typical performance monitor files are if you let them run essentially forever. You'll see that that's a lot of data that you're going to have to store. And so what we have here is an ability to store data on the basis of its level of optimization. If you'll see here, with high optimization, we are essentially using almost calculus to understand where the curves are in a more general sense as opposed to in a more specific sense. We're looking at the area underneath that curve from a larger box as opposed to looking from a smaller box. You'll see here that high optimization stores less data in the database as opposed to storing more data in the database, but that less data is less accurate. You can look at this in the sense of, instead of storing performance information every 15 minutes, maybe I'm storing it every 15 hours. Or instead of every 12 seconds, I'm doing it every 12 minutes. If I use optimization, what that's going to do is set the tolerance associated with the absolute number and percentage for how much data that I want to include in for my samples. I click the Create button, and that actually creates the rule. Once that rule is created, it will begin the process of actually pulling that data in and will allow me to later on create a view associated with that rule. Let's go through a different example. Let's say that instead of creating a rule based on performance, we want to create a rule based on the event log. In this case, I can choose Collection Rules Event-Based and look at the NT event log, change the management pack down here to My Server Performance, and then on the next screen, actually choose information about the rule, what I'm looking to do. In this case, My Event Log Rule. Again, a custom rule category at this point, and select the rule target that I'm interested in. I'm going to put that back on Windows Server 2003 computers. Lastly, I have to choose what event log I'm interested in. Am I interested in the system event log, or the application event log, or one of the custom event logs? And lastly, what types of events am I interested in pulling as part of this? Do I have particular event IDs that are interesting to me, or particular event sources that I can do as well? I can insert those in here or insert in additional categories as I see fit. There are a number of common event properties associated here: log name, login computers, full event number, event source, etc., to specifically tailor down the type of events that I want to pull in based on this rule. Later on, once I've created the rule, maybe I can use a monitor to monitor the rule and then provide information about and alert me whenever that rule is having behaviors that I want to be alerted on. So that's the process of using rules. Let me spend a second or two here to summarize the difference between rules and monitors. And it's easiest to do that if we go back here into the monitoring node. If we look on here on the monitoring node again, and we look at computers and we see this statement of health, the way that we populate our computer statement of health is done through monitors. The monitors let us know through all of those various tree-type formations the roll-up of the status of all of the computers in my environment. I do that and customize that by creating new monitors. If I want to create new rules allow me to do other things, like identify alerts, for example, or even populate some of the information down here, like the performance information, or the status information, or the event log information. Those allow me to create custom information for my Operations Manager console. With this in mind, I want to revisit the last topic for this nugget, and that's involved with self-tuning thresholds. We've taken a look at a couple of different monitors, and we've taken a look at a couple of different rules at this point. But what we want to do is actually take a look at a particular type of monitor that actually can change over time. What we're looking for here is a monitor, unit monitor, of a particular type. Under Windows Performance Counters, you'll see these monitors here called self-tuning thresholds. Now you can think of the problems of performance over time and the issues associated with alerts related to that performance, right? Now, the person who invented this management pack may have identified 95%, for example, as a level of performance that the server is considered to be bad. And you may have identified 80%. But how did you come to the level where you thought that 80% was bad and 95% was even worse? You came to that point because you looked at your servers over a period of time and identified what their standard behaviors are. Now you did that through probably a subjective method. Operations Manager uses self-tuning thresholds to create a quantitative measurement for what is nominal performance over time. Let's talk about this. Let's look at a two-state baselining rule here, a self-tuning threshold, and again, let's put this back under My Server Performance, the management pack. What this is going to do is, instead of identifying a hard rule associated with performance, it's instead going to look at rules over a period of time. My self-tuning threshold. It's going to look at rules over time to help you identify when a system is not necessarily going over a hard threshold, but when it's going over a threshold of its normal behavior. I'm going to look at a parent monitor of availability here and look at a performance counter. Let's look at CPU because it's easy to look at. If I click on performance here, processor here, and we again look at percent processor time in total, I'm going to add that into my environment and check my interval every 15 minutes. Now, as opposed to just setting this as a hard and fast limit where I'm going to be alerted on it, what I want Operations Manager to do is to identify what my period of use is for my server. In this case, it's called the business cycle. You think about the way you use a server over a particular day or a week or a month. Does your server have particular days of the month where it is very, very highly hit, when it's got a lot of use, or days of the week, or maybe even hours of the day? You can consider that to be your business cycle. Let's say you're a bank, and once a month you actually have the monthly processing that's involved. Well, your business cycle then is considered to be 30 days. And so over that business cycle, you can actually have Operations Manager baseline the performance to identify when periods of high activity and periods of low activity are actually occurring. Once it is identified and learned what your behaviors are, it can then begin generating alerts after a certain number of business cycles of analysis. We have a sensitivity level here where we can identify at what point do we consider ourselves to be over that typical baseline of use. This allows us to identify not necessarily when a server hits a hardline threshold, but when that server again goes above its usual standards of performance. Here under health, when we're within that envelope, we consider ourselves healthy, but when we're above that envelope, we're considered to be critical. And lastly, I can choose to configure alerts as well. This is a really, really useful component of Operations Manager because it allows you to identify when your servers are performing in a way that they don't typically perform. This is usually indicative of some sort of problem occurring on that server. So what have we talked about in this nugget? We've discussed the issues of customizing monitors and rules. And while your head may be swimming at this point because there's a lot of situations involved and a lot of things that you may need to do to customize those monitors and rules, you've found that there really is only a very small number of ways in which you can go through that customization process. The first step is obviously creating a management pack for customization and then looking at the existing monitors and rules in relation to your environments and the behaviors in your environments. We talked about overrides and creating those monitors and rules, and then the special types of rules called self-tuning thresholds. I hope this has been informative for you, and I'd like to thank you for viewing.